Welcome to Student Voices. This segment, we're at Deep Run High School, where I'm going to be talking with students of the Deep Run Robotics team, better known as Team 1086, but this year, better known as the Blue Cheeseheads, and we're going to learn a little bit more about that. As we talk today, I'm going to learn more about this whole robotics program with students. One of the most interesting things is that this has been a highly competitive team, as well as several other teams that Deep Run has worked with in partnership. The great news for Henrico County and Deep Run is the 9th annual robotics competition at VCU, which featured how many teams?
About 64 teams this year.
64 teams from really all over the East Coast. Deep Run was one of the championship teams, team number 1. So talk a little bit about the success at Deep Run this year and what happened at VCU.
I guess what really started this year was we completely switched themes. This was a really rebirthing year for our team. We used to be known as the Pirates of the Black Pearl, which, you know, was cool when the movie came out. But there's nothing about pirates that really connects with First. Pirates are kind of not very usually the good people.
So how did we end up with the cheese theme and connecting with robots?
Well, it's a bit of a stretch, but one thing we're known for, or that we think is really cool, is our main sponsor, Flexicell. They run a machine shop, and they cheese out our frame every year. Our robot frame has a lot of holes missing to save weight, and someone said, well, let's try and stick with the school some, so we took the color blue, and we threw them together, and we ended up with blue cheese.
Hey, that's a great way to go. Introduce yourself, please.
My name is Colin Winmuller. I'm captain of the 1086 robotics team.
And Colin, what grade are you in?
I'm a senior.
Okay, so this year you changed the theme, a completely different kind of robot. Now, where's the robot right now?
Right now, the robot is in Atlanta. We can't access the robot. We don't have any way to alter anything until national competition. April 17th, that's when we start at the national level.
I know in a minute we're going to learn more about last year's robot, which we have here, but I think it would be important for our audience to know. I had a chance to attend the competition at VCU this year. It was really exciting, and watching the semifinals and finals, it wasn't an easy road to the championship, was it?
No, not at all.
What did you learn from the process as you guys were working on this year?
Well, the two main things that end up winning the competition is teamwork and dedication. The only reason we were able to pull together in the end and come out of a bind like that was because everyone was there doing their part, working together. Actually, there was something wrong with the machine. We weren't firing properly. The main way we score, by throwing balls over the hurdle, it wasn't working. We didn't know what it was. So we grabbed everyone. They were right there the whole time. Everyone was checking everything. We looked over that thing 30 times. We eventually found out what the problem was. We fixed it. We went straight into competition, and we were okay. We scored, and
I can't remember the time, but it seemed really tight.
it was definitely short on time, a matter of minutes for us to try and find the problem and fix it. Everyone had to do their job just perfect for us to be able to fix that problem in time.
Well, clearly the teamwork this year. Talk a little bit, introduce yourself, and then tell us a little bit about the robots.
I'm John Coots. I'm a sophomore. I work on electrical parts of the robot and pneumatic parts. Our robot this year and last year we used something called a Mecanum drivetrain. That kind of lets us strafe to left and right, as well as turn like a normal, kind of like a tank.
You work in partnership with one of our other schools, the Sparky team. Which school is that?
Team 384.
384, and they're from which high school?
Tucker High School.
Okay. And that's a little unusual. Typically teams work on their own. What's the design that you all end up working with Tucker?
We just decided that we wanted to kind of share our resources, our mentors, and our design talent, I guess. We kind of tried to divide the design up and share the different responsibilities with them.
Now, the mentor that you've been working with the last couple of years is Flexicell. Mm-hmm. Where are they located?
They're located in Ashland. They work on robotic palletizing and packaging equipment, which is basically just getting food prepared to ship, and they do that all with robotic arms.
So one of the great parts about this program then is, as students, you all have a chance to work with people in our business technology community. They're actually working on robots, and they're asking you questions, but you all are doing all the work in terms of putting this thing together, right? Mm-hmm. Well, I understand that there's some community service aspects of this, so let's turn to a couple of other students. If you all would introduce yourselves, and then we'll talk a little bit about that part.
Oh, okay. Well, I'm Sarah Bailey. I'm the team secretary.
And what grade are you in, Sarah?
I'm a senior.
A senior.
And I'm Brian Rutherford, And I'm a junior.
And junior. Okay, talk with our audience about the community service aspects of FIRST Robotics.
Well, I think the FIRST program is about a lot, and certainly a couple of those parts being the business aspects and the community service. Students are responsible for raising a great deal of money and the timing that basically we work year-round to do that. But along with that, it's important to reach out to your community and show what a great program this is and the benefits. And so we've done that through, we've sponsored 3 FLL teams, and our team.
What's an FLL team?
It's a FIRST LEGO League team, which is basically FIRST is made up of 3 to 4 programs. There's FIRST LEGO League, FIRST Tech Challenge, and FIRST Robotics Competition. And our team sponsors 3 FLL teams, comprising of about 30 middle school students, and 2 FTC teams, which is about 20 students in the middle to high school levels, and an FRC team, of course.
Which is us.
Mm-hmm.
Okay, and that's this team.
That would be, yes, that would be Blue Cheese.
So part of your outreach then is reaching out to younger students, and they're using Lego parts to
Lego
design
parts.
robots,
Yep.
but there's still programming and other things going on. It's just
Yep.
a smaller kind of robot?
Also, we work with, every year, Dean Kamen, who founded the FIRST program, gives homework to teams. 2 years ago, his homework was to fill the stands and get FIRST out into your community. And so this year we had about 100 people in the stands.
You really knew where the Deep Run crowd was with these extraordinary hats.
And along with that, this year's was to reach out to your politicians. So we wrote to several.
To U.S. Congressman Cantor, Delegate Janis, and Senator Stosh. Last year's homework was media coverage. It was a big deal, and we were really stressing to get media coverage, and we're very proud.
What happens is there are 2 opposing teams, generally red and blue, and red is usually comprised of 3 robots, and it could be multiple schools, and versus another 3 set of robots. And you'll find out sometime early that day what the schedule is and who you're paired with and who you're paired against.
So multiple teams working together, and then as you progress and you win at different levels, then you begin to identify teams to work with depending upon your ranking. So all that scouting that plays out as you move ahead.
What ends up happening is you can kind of say that it's 2 tournaments in one. They're the qualifying rounds which create your rank. Then at the end of the competition, the top 8 seeded teams pick 3 other teams to be their partners. And then the tournament starts all over again. And at that point, it's a double elimination. So you've got to win 2 matches to advance on.
Right.
And so now it's kind of like the NCAA. Number 1s versus number 8, number 2s versus number 7. And so finally it trickulates down to the finals.
So there are multiple opportunities, but part of the real emphasis of robotics is that there's a real connection between the different teams.
It's Team 1086 from Glen Allen, Virginia.
Obviously, you all are using computers. What kind of programming goes into making these robots work?
We use C. It's a very basic programming language used just for simple robotics. IFI provides us with a processor. They give us the software called MPLab, and essentially they give us all the tools we need. It's our duty to learn the material and teach it on, pass it on, so that the next team's ready to get the robot moving.
So all the teams, wherever they are in the country, then get the same tools.
Yes.
And as I understand it, what happens in